Lesson: Ensuring transparency and explainability in AI decisions. Ensuring transparency and explainability in AI decisions is increasingly vital as artificial intelligence becomes ubiquitous in various sectors, from healthcare to finance and beyond. This necessity arises not only from ethical considerations, but also from legal and operational requirements, ensuring that AI systems are both accountable and trustworthy. Transparency refers to the openness and clarity with which AI processes and decisions are communicated, while explainability involves making these processes and decisions understandable to humans. Achieving these objectives is essential for fostering trust and enabling effective governance in AI applications. To ensure transparency and explainability, professionals can implement several actionable strategies and leverage practical tools and frameworks. One effective approach involves the use of interpretable models. These models, such as decision trees and linear regression, inherently provide transparency due to their straightforward structure. For instance, in a decision tree, each decision node clearly represents a choice based on a specific feature, allowing users to trace the decision path easily. However, interpretable models might not always capture complex relationships within data, necessitating the use of more sophisticated models. For more complex models, like deep neural networks, which are often treated as black boxes, techniques such as local interpretable model agnostic explanations and shapely additive explanations can be utilized. LIME explains model predictions by approximating the complex model locally with an interpretable one. This technique allows professionals to understand how input features affect predictions for individual instances. SHAP, on the other hand, provides a unified measure of feature importance by considering the contribution of each feature to the prediction, based on cooperative game theory. These tools are particularly useful in domains like healthcare, where understanding the rationale behind a diagnosis or treatment recommendation is crucial. Incorporating transparency and explainability also entails using frameworks that prioritize these principles from the outset. The Responsible AI framework by Microsoft, for example, emphasizes the importance of fairness, accountability, transparency, and ethics in AI development. By integrating these considerations into the AI lifecycle, organizations can ensure that systems are designed with stakeholder needs and regulatory requirements in mind. This framework encourages the use of bias detection tools and fairness metrics to assess and improve model performance, thereby promoting equitable outcomes. Moreover, transparency in AI systems is enhanced by adopting a robust documentation process, as recommended by the Model Cards framework. Model cards provide detailed information about a model's intended use, performance metrics, and potential biases. This documentation facilitates better understanding and communication among developers, users, and stakeholders, ensuring that AI systems are used appropriately and effectively. For instance, Google's use of model cards has improved transparency in their machine learning models, fostering trust and accountability. Practical applications of these strategies can be seen in various real-world scenarios. In the financial sector, for example, AI models are used to assess creditworthiness and detect fraudulent transactions. Ensuring these models are transparent and explainable is crucial for compliance with regulations, such as the General Data Protection Regulation, which mandates that individuals have the right to an explanation of decisions made by automated systems. By implementing explainability tools like LIME and SHAPE, financial institutions can provide clear justifications for credit decisions, enhancing customer trust and regulatory compliance. Another instance is in the healthcare industry, where AI-driven diagnostic tools must be transparent to gain acceptance from medical professionals and patients. The use of interpretable models and explainability techniques allows healthcare providers to understand the factors influencing a diagnosis, thereby facilitating better clinical decision-making and patient communication. A study by Caruana et al. Demonstrated that interpretable models could achieve performance comparable to complex models in predicting pneumonia risk, while providing clear insights into the decision-making process. In addition to these strategies, fostering a culture of transparency and explainability within organizations is essential. This involves training AI practitioners and stakeholders in ethical AI practices and the use of explainability tools. Organizations should also establish governance structures that oversee AI deployments, ensuring compliance with ethical standards and legal requirements. This proactive approach can mitigate risks associated with AI systems and enhance public trust. Despite the availability of tools and frameworks, challenges remain in achieving full transparency and explainability. Complex models may still pose difficulties in understanding intricate decision-making processes, and the trade-off between model accuracy and interpretability can be a significant concern. Ongoing research in the field of interpretable AI seeks to address these issues, aiming to develop models that balance complexity with clarity. In conclusion, ensuring transparency and explainability in AI decisions is a multifaceted endeavor that requires the integration of interpretable models, explainability tools, and ethical frameworks. By leveraging techniques like LIME and SHAPE and adopting frameworks such as the Responsible AI Framework and Model Cards, professionals can enhance the transparency and accountability of AI systems. These efforts not only address legal and ethical considerations, but also foster trust and confidence among users and stakeholders. As AI continues to evolve, it is imperative for organizations to prioritize transparency and explainability, thereby ensuring that AI systems are not only powerful, but also responsible and trustworthy.